In solving quadratic equations, we're going to look at the first two methods of several ways that you can solve those quadratics that we've been looking at for the past couple of weeks. So our target is that we will solve a basic quadratic algebraically and identify quadratic equations that have no real solutions. So these can be solved, meaning quadratics can be solved in a variety of ways. You have graphing, you have square roots, factoring, completing the square, and using something called the quadratic formula. In this lesson, we're going to be looking specifically at graphing, which you will probably lean toward. That's going to be one of your more preferred methods, especially if you have that graphing calculator. And then also square roots, where when it turns out as a perfect square, then it's very easy to solve. So standard form of a quadratic, like you know, is ax squared plus bx plus c equals 0. You have all of those terms on one side. The a, the b, and the c look like numbers, then the x squared and the x remains. And so a very key idea of this whole chapter is that the x-intercepts, they are the solutions to the equations, and these are also known as the roots or the zeros. Think about when we did systems of equations, you'd have your coordinate plane. You don't have to draw this system, and you would have a line here and a line here, and we learned that right here at the intersection was the solution to the system. Quadratics are going to work kind of in the same manner. Where they cross the x-axis, those are the solution. So we are talking about this right here and this right here. Those are called the zeros, or you might also hear them called the roots. A review of what we saw previously with this U shape is called the parabola. It is symmetrical, and that's across here at the axis of symmetry. Either the highest point or the lowest point, the minimum or the maximum, is called the vertex. Here you have the y-intercept, which is not really something we're going to be looking at. We're looking more at those x-intercepts, like these right here, and those are the zeros. The first method of solving quadratics that we're going to see this chapter is graphing. So let's take this equation of y equals x squared minus 4. Keep in mind that the x-intercepts are the solutions. So if we were to graph this, we would make this table, and this would make sense if I put negative 3 in there. Negative 3 squared is 9. 9 minus 4 is 5. If I put 0 in there, 0 squared is 0. Minus 4 is negative 4. If I put 2 in there, 2 squared is 4. 4 minus 4 is 0. So let's go ahead and graph these. Negative 3, positive 5. Well, say that 1, 2, 3, 4, 5. Okay. Negative 2, 0. Negative 1, negative 3. 0, negative 4. And then I can tell that the y-axis is actually going to be my axis of symmetry, because 1, negative 3 is another coordinate. Then 2, 0, and 3, 5. So let's attempt at drawing that up there. Kind of a U shape, has a curve to it. So there is my parabola. Its solutions are going to be right here at the x-axis. And do you see why those are also called the zeros? Negative 2, 0, and 2, 0. It's called the zeros because the y-coordinates would be 0 in order for it to be an intercept. So my solutions are negative 2 and 2. So you could say that is plus or minus 2, or you'll see it like this, 2 and negative 2. That could also be a solution. Sometimes you'll see it written as coordinates, negative 2, 0, and 2, 0. So quadratics can have 2, 1, or 0 solutions. So let's try to see how each of these would look. If it has 2 solutions, that means that there are 2 places that it's crossing the x-axis. So that could be like right here and right here. So if it were, well, that looks bad. Let's go more like that. Could look something like that. Or I'm actually going to fit 2 graphs on this one coordinate plane here. It could also point upward if it looked like this, there's a skinnier one, it's crossing at two places, either one of those. One solution, that's going to mean that the vertex is on the x-axis, so right there. It has one solution, it's only crossing at one spot. No solution could be something like this. Have a vertex here, and it's going to extend infinitely down, so it's never going to cross the solution. It has a graph, but that graph does not have a solution. The second method that we're going to look at are square roots. So here are a couple examples for you, and over on the right side you'll see the how-to on how to solve these. So your first step is that you're going to isolate x squared, meaning that you're going to get x squared on a side by itself. So in order to do that, think of this y as the 0. And that makes sense because if we look back at our graphs, the solutions are where it crosses the y-axis, and that is where y is equal to 0. So think of that as 0 equals x squared minus 36. I'm actually going to move this equation over here to make some more room for us. So then I can undo that subtracting 36 by adding 36 to both sides. Okay. Then I'm left with 36 equals x squared, negative 36 and positive 36 cancel. And then I'm able to take the square root of both sides. So let's go ahead and do that. Square root of 36, square root of x. The square root of 36 is either plus or minus 6, because I could do negative 6 times negative 6 to get positive 36. And as you saw on that last graph that we did, the solutions were positive or negative 2. Same thing could happen here. And the square root of x squared is x. So there are your solutions. And if you write those as coordinates, that would be negative 6, 0, and 6, 0. Let's look at this other example of y equals 3x squared plus 15. Remember, our first step is to isolate x squared. So we would subtract 15 on both sides. I'm going to go ahead and make that y the 0. 0 minus 15 is negative 15 equals 3x squared. 15 minus 15 cancels. Then I'm going to undo multiplying by 3 by dividing by 3 on both sides. Negative 15 divided by 3 is negative 5 equals x squared. Then I'm going to take the square root of both sides. And if you were to put the square root of negative 5 into your calculator, it's going to give you some sort of error, because you cannot have a square root of a negative number, because there are no two identical numbers that you can multiply together in order to get a negative. Think about negative products. They have to have different signs. So this one is no solution. You either see a 0 with a line through it or the actual words no solution. So the graph of this equation is going to look like one of those where the parabola is below or above the x-axis and it's going in the opposite direction.